Okay, this video is for section 3 of chapter 7. We've spent some time talking about rational exponents and the relationship between rational exponents and radicals, a little bit with simplifying those. We're going to switch gears a little bit, and we're going to talk about operations on functions. Okay, and we're talking about the basic operations. We're going to talk about addition, subtraction, multiplication, and division. And we're also going to talk about composition of functions, which is going to be something a little bit new to you. So as you look up above in the directions on this page, okay, you have three functions given in the directions. You have f of x, which is a quadratic, x squared minus 1. You have g of x, and you have h of x. Both g of x and h of x are both linear functions, 2x minus 3 and 1 minus 4x. And what we want to do is, in the first column, part A, they ask you to perform the operation on the function. In part B, they ask you to evaluate that answer for a specific number. And I'm going to show you a couple different ways you can go about doing that. Okay, so on number 1, okay, number 1 is talking about subtraction. I want to take f minus g of x. Okay, now to perform a subtraction problem, what I want to do is I want to take the two functions and I want to plug them in. F minus g of x is the same thing as f of x minus g of x. Okay, so if I go back up there to what the original equations, and I'm going to put these in parentheses here. Okay, it's kind of important with subtraction so that I distribute that sign through. X squared minus 1 minus 2x minus 3. Okay, now to subtract, I need to distribute the negative through, and then all I'm going to do is combine the like terms. So the 2x is going to become negative. The minus 3 is going to become positive when I distribute. So x squared, there's nothing to combine with that. I have a minus 2x, nothing to go with that. And then I have this minus 1, and then by distributing this plus 3, which would leave me with a plus 2. Okay, so f minus g of x becomes this trinomial after you distribute the negative and combine the like terms. Okay, now what I could do for part B is I could take the number 3 and plug it into that. Okay, so, but I'm going to show you another thing I can also do. Okay, so if I take f of 3, just like I said previously, minus g of 3, instead of subtracting, plug the numbers in first. Okay, so when I take the function x squared minus 1, this becomes 3 squared minus 1, and minus, plugging the number 3 into g, 2x minus 3 becomes 6 minus 3. So this is 8. This is 3. And 8 minus 3 is 5. Now again, plugging the number 3 in here, 3 squared is 9. 2 times 3 is 6. 9 minus 6 is 3 plus 2 is 5. Same answer. So it doesn't matter whether you plug it in number 3 in here, or you plug it in both here and then perform the subtraction. Both answers or both situations must give you the same response. Okay. On number 4 and 5, okay, you have multiplication. Okay, so we need to be careful though, because what we're multiplying are actually binomials, And to multiply binomials, we have to FOIL. So on question number 5, give myself some room here. Question number 5, I want to take f times g. Same functions as I used above, but this time it's hard to see on my paper, but there's a dot there, meaning multiply. Okay, so in this case, I want to go x squared minus 1 times 2x minus 3. And now when I FOIL, this becomes 2x to the third minus 3x to the second on the outside minus 2x on the inside and then plus 3. Okay. Now, as you look at that, the next step is to combine like terms, but there aren't any. So because there are no like terms, that would be your answer. Okay. Now again, part B. You can take the negative 1 and plug it in for x, or plug the negative 1 into both originals and then multiply the results. So if I have negative 1 squared minus 1 times 2 times negative 1 minus 3, then I get negative 1 squared is positive 1. Okay. Positive 1 minus 1 is 0. This is negative 2. 2 times negative 1 is negative 2 minus 3 is negative 5. Looks like you're going to get 0 out of that result. So let's see what happens here. Okay, negative 1, that makes this a negative 2, minus 3, plus 2, plus 3. Okay, these are the results you get when you plug in negative 1 into this. Again, everything drops out. So here is your answer to the first part. Here's your answer to part B. Okay. Of the 4 operations, division, which is on 6 and 7, is probably the one that you can do the least with, because with these binomials, the only thing you can do to divide these algebraic terms is factor and cancel, and most times not much will happen. So on number 7, okay, I'm going to take G over H. So plug in. G is 2x minus 3. H is 1 minus 4x. Now, you're not allowed to cancel the 2's, 2 and the 4, or really do much of anything. So because there are no common factors, okay, in the top and bottom, that's done. That's your answer to part A. Now, again, plug the number in. If I write this as G of 0 over H of 0, that means I've got to plug zeros in for all of those x's. When I do that, I get a negative 3 on top and a 1 on the bottom. That leaves me with an answer of negative 3. Okay, so that could be done either way. Plug the 0 in first and then divide, or divide first and then plug in the 0. Either way, you get the same result. Okay, so that's what I'm asking you to do here. Finish that front page. And those shouldn't be, any different than the ones that I've given you. So you should be okay with those. Okay, the back side of this worksheet, however, is going to talk about a different concept. Okay, again, I want you to note in the directions on the top of the page, they've given us some different expressions, okay? And in each one of these, they're asking, well, except for the very end, the last three, they're asking us to evaluate, okay, which means test it for some specific number, okay? So I'm going to pick out a couple, but these are called compositions, okay? And when you perform a composition, what you literally do is you substitute one function into the other. It's a substitution process, okay? Now, remember when your order of operations, you go inside out, okay? The same thing is true here, okay? So, well, number 3, for example, when it says g of h of 24, that's literally telling me I want to take the number 24, I want to plug it into the h function, and then I want to take that answer and plug it into the g function. And what do you get? What you get after that succession is your final answer. So they're a little bit different on the exercises. F of x is 2x minus 1. You have a binomial there. G of x is 3x. And then h of x is x squared plus 1. So we have 3 functions there. Let's do number 2. Number 2 says I want to take the number 7. I want to start out by plugging it into h, because h is the first one that's there. Okay, so when I take h of 7, okay, that means substitute the number 7 into h. So x squared plus 1 becomes 7 squared plus 1, okay, which is 50. Now, take that 50 and plug it into f. So f of 50, or 8, let's write it like this first. F of h of 7 now becomes f of 50. When you plug in the number 50, 2x minus 1 would be 2 times 50 minus 1. So 100, so you get 99. Okay. Now you have some positive numbers, you have some negative numbers, you have 0. They're going to take you through several different kinds of responses. Let's do number 9 where we got a negative number, and then I'll show you one like the 10 through 12. The rest of them are going to pretty much all be the same. Number 9 says G, oh, got 3 of them here. Okay. So this time I want to go -6. I'm going to plug it into H, and then take that answer, plug into F, and then take that answer and plug into G. You work your way from the inside out. Okay? So I want to start out with H of -6. So -6 squared plus 1. You get 37. Take that 37, plug into F. F of 37 equals 2 times 37 minus 1. Okay? Which is 73. And then I want to take G of 73, which is equal to 3 times 73. From there, I get like 219. Yes. So final answer then would be 219. Okay, final answer is 219. Okay. And And then on the last three problems, okay, in these examples, I want to go from, again, inside out, but this time you're substituting a function back into itself, okay, and you're leaving it in terms of x. So you're not plugging a number in, you're plugging an actual function in and then simplifying, okay? So on number 12 is going to be the tough one. So I want to take h of x, which is that x squared plus 1, and I want to plug it into h of x. So h of x, I already know is x squared plus 1. So that means h of x, the of is how you read a composite function. I want to take that x squared plus 1 and substitute it in for x. So x squared plus 1 becomes x squared plus 1 squared plus 1. Okay? Now, x squared plus 1 is something, when you square it, is the same thing as you would rewrite it and FOIL it out. Okay? So I need to simplify this expression to get rid of the square, get rid of the parentheses, to get my final answer. And that's what you need to be aware of here. So when I FOIL out x squared plus 1, I get x to the 4th plus, and I'm simplifying as I go here, plus 2x squared plus 1, and then plus 1 again. Okay, so 2x squared plus 1 squared, when you FOIL that out, you get this. Now, combine the like terms, and you get x to the 4th plus 2x to the 2nd plus 2. There's your final answer. Now, because this is a quadratic that got a little bit more involved with having to do the binomial square and FOIL, 10 and 11, where you have a linear and a monomial, those should be a little bit simpler to do, okay? But the ones that we did where you're evaluating, again, start inside, work your way outside, and you should be okay with those, okay? So if you have additional questions on any of those that don't seem to be working out right, email me and I'll write up some other solutions and post them for you to see. But just give me a holler if you're struggling. Give me an idea of how you're doing. Okay? Thank you.